Ladies and gentlemen, people of the internet, today we're talking about the Cosmos network, and more specifically, I'm going to explain the major components that make Cosmos such a powerful player in the blockchain space. Now, if you want to learn more about Cosmos and other cryptocurrencies, make sure you get subscribed and hit the bell. Now, I know your time is valuable, so let's just go ahead and hash this out. Now, the first thing I wanted to talk about today is Cosmos's history and sort of an overview of the project to date. Now, Cosmos is an ambitious and highly regarded blockchain project that's been working towards the goal of creating a composable blockchain network ecosystem that allows the many blockchains of the world to interoperate with one another. In other words, it's the internet of blockchains. In Cosmos's grand vision, virtually any blockchain network will be able to share data and transact securely with one another in a deeply interconnected and secure network. In other words, Cosmos is aiming to bring an end to the fragmentation and protocol maximalism that has plagued the cryptocurrency and blockchain space since its advent. Now, Cosmos itself has been around since 2017, when its original concept and token sale took place to raise capital for the build-out of its unique and ambitious tech stack. In March of 2019, Cosmos's mainnet launch occurred after 2 years of work, and now in 2021, where we sit today, Cosmos has launched its most consequential update in history, the first version of its InterBlockchain communication protocol, or IBC for short. Now, I'm going to break down the details on IBC, how it works, and why it's so important, but that's coming a little bit later. Make sure you stick around. I need to give you a little bit more context on the overall design and architecture of Cosmos to make sure that all of this makes sense in context. Now, the Cosmos network sort of has this fundamental architecture, which was inspired by a network topology or system architecture model called hub and spoke, which refers to an environment where one or more central relays or orchestrators are used to connect many other connected networks or services. The name hub and spoke comes from the visual topology that it renders, which looks like a wheel with a central hub and many spokes coming off of it. Cosmos implemented this model as a means by which to facilitate broad blockchain network interoperability with two well-defined network types, hubs and zones. In essence, hubs are the connective tissue that ensure secure, stateful communication between many zones, which are heterogeneous blockchain networks that communicate with each other through the hub network. So zones connect to each other through the hubs. In this way, a zone can be a purpose-built blockchain protocol for NFTs or for DeFi, for example. And then that can communicate with another zone that specializes in synthetic asset exchange through a central hub. Effectively, this means that a zone chain only has to connect to one or more hubs to connect to many different zones, using those hubs as relays. The first major hub in the Cosmos network is the proof-of-stake Cosmos Hub, which serves to connect several zones in the network today. Now, this Cosmos Hub is where the native Atom cryptocurrency is used as an economic lever to facilitate the consensus mechanism and governance of the network itself. In short, governance on Cosmos is facilitated by staking of the native Atom cryptocurrency by network participants who compete to be in the top 125 validators by stake, meaning the more stake you put up, the more likely you are to become a validator. And these validators across the network are responsible for validating and minting blocks in the network, and non-validator users can delegate their Atom to validators for a share of the revenue of block making rewards, of course. However, validators who misbehave can, of course, be slashed or penalized by losing their staked Atom, which can also hurt delegators. So be mindful of who you're delegating with, because it's really, really important. And these validators also vote in proposals for updates or changes to the network, which is a critical role in any blockchain. So delegators will, of course, delegate their Atom to validators that are voting the way that they want them to vote, but there are means to override the validators' vote in cases where delegators do not align with the validators that they are connected to. It's a digital democracy in a way, if you think about it. Now, as we continue to talk about the layers of the Cosmos ecosystem, remember the general structure of the network and the consensus and governance that we just talked about per the Cosmos Hub and validator mechanism. Now, in order to fulfill this vision of a deeply interconnected hub zone model, there was a need for a modicum of abstraction in the core layers of the blockchain network itself, enabling developers to quickly build Cosmos-compatible blockchains with a set of common tools. And in this context, the core layers we're concerned about in a blockchain are the networking, consensus, and application layers. I'm going to explain this. The consensus layer sits at the very base layer, and it governs how members of the network reach consensus on the state of data in the system. The networking layer sits right above that, and it manages the communication between network members. And then finally, the application layer is where the differentiated use case specific features are built, such as implementing proof of stake, governance features, tokenization, and more. This enables each blockchain to be built to a specific need or a specific use case or application rather than generically for a broad set of use cases, which is something we see more and more today. So this generally ends up rendering better performance when you build something for a specific purpose. Now, at the base level, the networking and consensus layers of a blockchain protocol ultimately determine how a network reaches agreement on the state of transactions and data in the network, and then communicate that with other systems. Therefore, it was critical to develop a powerful framework for these two layers, on top of which use case specific blockchain application layers could be built. And this is where the first of the major technical components of Cosmos came into play, and that is the Tendermint engine and the Cosmos application blockchain interface. One of the premier inventions that's been developed in Cosmos history to date is the Tendermint Byzantine fault-tolerant or BFT consensus and networking engine. BFT itself is built upon a classical model for designing systems that can handle individual component failures without failing altogether. And in this case, that system is a decentralized network that must be able to reach consensus without side effects, even in the presence of malicious or unresponsive members on the network. The Tendermint BFT engine offers a powerful networking and consensus layer that developers can use to drastically reduce the development effort that's required to build a Cosmos-compatible blockchain. Not only that, but Tendermint is also extremely powerful as the core heartbeat of a decentralized network in its own right, offering as low as 1 second block times, thousands of transactions per second, and instant finality, which is fundamental to the entire trust model of Cosmos's hub zone model. Tendermint is so well qualified, in fact, that it's been used as an open source framework in many other blockchain projects already, and has quickly become one of the most battle-tested consensus frameworks in the blockchain space at large. Now, if some of that didn't make sense, don't worry, we're going to talk more about it in a second. Now, I did also mention the Application Blockchain Interface, or ABCI, which essentially is the programming language agnostic interface layer between one's custom blockchain network application at the very top of the stack and the Tendermint engine that governs that fundamental layer. So it's this little mesh, the glue that holds things together. So without needing to understand all the technology mumbo jumbo, the ABCI can best be described as analogous to a translation layer that will shuttle requests and instructions from the custom components of a blockchain to the standard Tendermint engine that interacts with the broader network. So today, the main way one actually takes advantage of this ABCI layer to build on top of the Tendermint engine is through the Cosmos Software Development Kit, or SDK, which is a set of modular components that developers can use to build their custom blockchain applications to their exact use case or specifications. Using the Cosmos SDK, a team building out a Cosmos-compatible blockchain network can quickly build features like proof of stake with largely pre-built components in the SDK itself, which of course accelerates the development of these critical features exponentially because you don't have to start from scratch. In effect, the major functional layers of a blockchain network become far less of a hurdle for developers and project teams, so they can focus on building the community and peripheral software that's much more important to adoption. The Cosmos SDK makes it easier to implement use case specific functionality on one's network, such as enabling proof of stake or governance functions, and that is really the key of it. An example of a fully functional zone blockchain in Cosmos is the Ethermint chain, which uses the core Tendermint engine and the ABCI interface to connect to an application layer that runs the Ethereum virtual machine. The result is a super fast proof-of-stake Ethereum compatible network that works with essentially all the existing Ethereum tooling and contracts. And this is powerful stuff here. With the Tendermint engine at the networking and consensus layer, which is connected via the ABCI layer to a custom blockchain application built with the Cosmos SDK, you have yourself a fully functional member or zone in the Cosmos interoperability network. So this technological foundation is the crux of the beautiful, deeply interconnected hub zone network that has long been the Cosmos vision. And that said, like I mentioned before, these sovereign blockchains must be connected to one another in a secure and efficient manner to really achieve that interoperability. And that is where the InterBlockchain Communication Protocol, or IBC for short, comes in. IBC was just released in its V1 form in the Cosmos mainnet ecosystem recently, and it is arguably the most important invention that has come out of the project in its history. IBC allows the various zones, each sovereign blockchain themselves, to connect to one another through the Cosmos hub. Remember that hub and spoke model. Now, earlier in the video, I mentioned the Tendermint engine for consensus and how it has some critical features for IBC to work. And one of those is the ability to have instant finality. Now, instant finality refers to the fact that blocks of transactions are considered final and immutable as soon as the block is minted, rather than based on a probabilistic model for reorganization like in Bitcoin or Ethereum's proof of work network, where you need many block confirmations to be sure that transactions are final. IBC itself is simply a protocol for the exchange of data packets between blockchain networks, which can be used to facilitate cross-blockchain transactions and data exchange. So let's take an example of a cross-chain transaction that moves from one zone to another. So we'll call them Zone A and Zone B. And of course, you have the hub the communication will travel through. So let's say for this example, Zone A is going to send coins to Zone B. Because the zone's blockchains are built on the Tendermint engine, both networks' block headers are being predictably recorded and are immutable upon creation. So both zones have instant finality and can keep track of each other's state. This is absolutely critical. It is why fast finality consensus like Tendermint BFT is a base level requirement for cross-chain communication. Zone B needs to know that Zone A has locked tokens in bond on its chain so that Zone B can consider the token transfer valid on its end. Validating that block header on each side is a critical part of the process. And the first step in that process is for Zone A to lock X number of tokens in bond, making them in effect inoperable on Zone A. And then it sends a proof to Zone B, or a signed digital record that says Zone A is sending coins to Zone B and that they've been locked in bond. It's like a promise. Then Zone B can use the block header and validator set contents from consensus on Zone A to verify that the proof is valid. At that point, Zone B can be certain that Zone A's coins are locked, so they can be safely used in Zone B. And boom, you've got cross-chain communication and transactions. This is an example of atomicity, which you might realize fits nicely with the Cosmos atom theme. That's no accident. Atomicity refers to the property of a transaction that requires all operations to be completed or nothing happens. Mechanically, in this case, that ensures that if coins are not locked in bond on Zone A, Zone B cannot consider those coins valid on its end. And if any step of the process fails, the entire transaction fails. This prevents instances where coins exist on both chains, which constitutes double spend. Now, I did mention that fast finality consensus is an important part of this process, and you can see why that is. Both chains need to be able to be confident that the other side will not reorg or change the outcome of a transaction or the state of a block, which happens in probabilistic finality chains like Ethereum fairly often. It's a normal part of the process. If that reorg happened in an IBC transaction, chaos would ensue because it would violate the atomicity principle that we just described. Both sides' operations in a transaction must be complete or it's invalid. This is why the Tendermint BFT engine is so valuable to Cosmos, because it offers that fast finality and characteristics that make it a perfect fit for IBC communication. However, there is a need for chains with probabilistic finality to be part of the Cosmos ecosystem as well, which is where the final topic of the day comes into play, and that is peg zones. These peg zones are effectively a fast finality proxy network between a probabilistic finality chain like Ethereum and Cosmos's broader ecosystem. It's an intermediary, if you will. In effect, the proxy's main task would be to establish finality for the chain in question and act as a fully functioning zone in the Cosmos hub zone topology. In practice, this would mean that every X number of blocks when an Ethereum block becomes final, the peg zone would follow the same steps outlined with IBC to validate a cross-chain transaction. For Ethereum, this would be constituted by, say, X number of coins being locked in a smart contract on the Ethereum mainnet and credited to the peg zone in Cosmos. Both sides need to be sure that the operation of locking on the Ethereum blockchain and crediting the vouchers on the Cosmos peg zone are completed and final. This method of connecting blockchains that do not share basic consensus characteristics of Cosmos chains, of course, can vary widely, so this is just a really general example to illustrate the concept. Now, in this video, we've talked about the hub zone network topology that Cosmos has envisaged so long ago. We talked about the accelerators that Cosmos has provided in the Tendermint BFT engine. ABCI, and Cosmos SDK that lets developers create Cosmos compatible blockchain networks easily. And we talked about how Atom sits at the center of the Cosmos ecosystem and drives the validator process across the network. We also talked about the dawn of the IBC era, which finally connects the Cosmos hub to the many heterogeneous zone chains that exist today, and how peg zones can be used to connect other blockchains that do not share the common foundations of Cosmos zone chains. Now, if you want to learn more about Cosmos, please check out my interview with Cosmos ecosystem developer Josh Lee, who has developed the most widely used Cosmos wallet called Kepler. We talked about IBC, we talked about the future of the Cosmos network, decentralized applications, and more. And I want to thank you so much for watching. I wish you a wonderful day and week ahead. And until next time, cheers.